So, hello everyone, and before we start, I'm pretty sure most of you have some point in your life have played any games like on PC or on PlayStation on or mobile. But I want to know like if anyone ever played any competitive games like Valorant, Counter Strike, or Apex. Okay, like some of you. So good. So I'm sure you must have encountered cheaters in that. So, and if you did, so you know how painful it is to play against them. Yeah. So, how do these hackers are destroying you and in destroying this gaming industry? So, in this talk, I'll be sharing my game hacking experience and few techniques that these hackers are using to out hack you all. And it's up to you what you want to do with this knowledge. You can maybe make a private cheat for yourself because you know you just suck at gaming, or maybe you just want to earn a lot of money because it's $1 million industry, and you can do that by selling your cheats. But you be careful because in some countries it's strictly illegal, like South Korea and China, and also, the skills that you learn in this game hacking can also be applied in other stuff like malware analysis. So, if you're wondering what the hardcore cheating looks like and how bad it is, so I've got here some example. So it's basically a nightmare. They won't even let you spawn, and as soon as you spawn in the game, boom, it's an headshot. So on the left, we got Valorant, which is very popular for its strongest anti-cheat in the market. And on the right, we have got Counter-Strike, which is also very popular, but for the worst anti-cheat in the market. So it doesn't matter how good anti-cheat is or bad it is, the hackers are still going to hack it. So a little bit intro about myself. I'm Rohan. I'm founder at Defco Security. I do bug bounties. I've participated in live hacking at HackerOne and Integrity, and I also love playing games, of course, without cheats. So this is what we're going to cover in this talk. I've divided this session. So first we'll see briefly like history of cheats versus anti-cheats. Then we'll cover some basics, and I'll show you some kernel cheat and external hardware cheats, and I'll show you some demos of both of them. So I also want to clarify what this talk is not about. So this talk is not about finding vulnerabilities in the game code or the server itself to exploit other users, other players. So this talk is all about gaining competitive advantage over others. So one of the very first game was made in 1957, and it was a tennis game, but it wasn't available publicly, like it was in a laboratory because they have very big machines. But at that point, gaming wasn't very popular, and it became popular in 1970s and 1980s when gaming consoles and home PCs were introduced to the general public. And in 1980s, modding of games started happening using command-style hex editors. And in 1995, first Aimbot was introduced for a game called Doom 2. But the thing started to heat up when these popular multiplayer games like Counter-Strike was introduced in early 2000. So you see, when cheating was done on a single-player games, there wasn't very much big impact. Like the cheat is only affecting the hacker itself; it's not affecting other player. But when you are cheating on multiplayer games, it's going to affect other players as well. And since the success of an online game requires a large and active user base, the developers can't let go of this. So in early 2000 came the very first anti-cheat called Punkbuster. And in 2002 came Valve anti-cheat. So these two were basically user mode anti-cheats, and they were initially very successful, but hackers soon discovered a way of bypassing them using kernel cheats. And here we are today. with some of the strong anti-cheats in the market kernel level, like Easy Anti-Cheat, BattleEye, and Vanguard. So, what's the term kernel and what's the term anti-cheat actually means? So, anti-cheat is basically, think of anti-cheat like a classic anti-debugger, and they have signatures for cheats. So, just like antivirus have signatures for viruses, so anti-cheat have signatures for cheats. And it's not only that, anti-cheat success depends on basically three things. How they are detecting the cheats, like signature, statistics, heuristics, and how they are discovering the cheats, like maybe finding them on their like the developers are finding them on their own, and how they are discovering new hackers. Like in game, they have a report system where you can report other players. And the third is prevention, how they are preventing, like using obfuscation, the binary, and sandboxing them. And these are some of the features of kernel anti-cheat. So kernel anti-cheat was a very big step for the good of gaming community. Like when it's launched, almost 95% of cheaters were instantly vanished from the servers. But of course, it can't stop like 100% of them. Even anti-cheat developers know that like someone will always be determined enough to find a bypass for it. And so what's the kernel? So a computer process usually have two modes, user mode and kernel mode. And the exe or application is usually loaded into user mode, and its core functionality is handled in kernel mode. For example, you open a browser, it will be loaded in user mode. And let's say you download some file and it needs to be stored on the hard disk. So it will make a system call to get the permission to store it on the hard disk. So the main point with respect to game hacking is that the user mode process don't have access to kernel mode processor in memory. So if an anti-cheat is in user mode only, since it doesn't have access to kernel level, you can load driver into kernel and the anti-cheat won't even know about it. So we can look into some basics. So when I initially started to learn game hacking, I had to decide between what kind of cheat I'll be making. So usually there are two kind of cheats, internal and external. So internal, as the name suggests, is they are injected directly into the game process itself, and because of that, they have great performance and they offer a great functionality. And of course, and they are complex to make because you need to be know about the engine on which they are made, on which the game is made. And for external, they have their own process and they manipulate the game's memory externally. And because of this, they need to make a call for every action. And because of this, their performance is low as compared to internal. And the functionality also they offer is less, but it's enough to get the job done. Like if you basically just want an Aimbot or Wallhack, you can do that on that. And they are a bit easy to make in comparison to internal, because there is no dependency on the game engine itself. So I went with the external method. So what's the methodology of bypassing a kernel anti-cheat? So as you can see, we have the cheat, we have the game, and in the kernel we have the anti-cheat driver, which is supposed to protect the game from other processes. So we are trying to read and write the memory of game, but as soon as we create an handle to it, the anti-cheat detects, because we are basically creating a handle, and the anti-cheat will use object register callback for detecting it, and as soon as we try it, it will block it. So how do we bypass that? It's simple. We basically have to move to the kernel level itself. So we will be creating a driver, and we will load into it into kernel, and we send the instructions whether we want to read and write for the game. So that being said, it doesn't mean even if you are using a kernel driver that the anti-cheat driver will not detect you. If you know what you are doing, if you don't know what you are doing, it will still detect you. So what will be the challenges in making this kernel driver? So first itself, how we can create the driver, how we can load it into the kernel, like are we even allowed to load any driver into the kernel, and how are we going to communicate with the driver from user mode, and how can we make sure that our driver is not getting detected by the anti-cheat driver. So we can move to the cheat development phase. So I've divided the whole step into whole process into the 5 steps. So the first is the reversing. So just like in pen testing, we are doing reconnaissance for information gathering earlier. So here also we are doing reversing for finding some of the game offsets. And then we'll be using hooking. Hooking is basically for communication between user mode and kernel mode. And based on that, we will be creating a driver for reading, writing the memory. And then we'll see how we can load the driver itself. And then we're going to create the user mode. So first is reversing. So usually in game hacking, what we are doing is we are reading, writing some address in the memory. So for example, if you want to change your player health to infinite, so you need to first find the address in memory where the health is stored. So for finding that address, you need to reverse that. And I found that there are 2 ways you can reverse the game. First is using debugging, and second is using disassembling. So I preferred to go with the debugger using cheat engine because for me it was easier and convenient. With IDA, with the disassembling, I need to first deobfuscate the game binary itself because they are heavily obfuscated. And for doing that, I need to dump the binary using a kernel driver. Also, for finding the offsets in using disassembler, I need to be well aware of the game engine itself, like whether it's in Unreal Engine or Unity Engine. So all these restrictions were not in cheat engine in debugging, so I went with debugger. So one of the term offset is very important in game hacking, especially for reverse engineering. So offset, what are offsets? Offsets are basically, as the name tells, how far is something with respect to another. So as you can see, we have starting point A and B is 12 kilometers away. So we can say that B offset is 12. And why is this important in game hacking? So let's say we launch our game. We get that it will be launched. It's launched as 0x123 address, and we reverse it. We find the health address is at 126. So next time we launch the game again, and if we try to access the same health address from like 0x126 in the second launch also, we won't find it because every time the game will launch, their addresses will keep on changing. So either we reverse the game every time or we find the offset of health. So as you can see in both of these, health is always 3 bytes away from the game binary itself. So instead of reversing every time, we can find the offset itself. And for finding the game address, we just have to use one Windows API, and we can get the game address. So this is a very simple example. So in real game, there are a lot of structures and lots of members in it. So I have another example to better explain it. So we have a game here, and in that we have structure for enemy and players, and members are same. And let's say I want to set the ammo of the player to 40. So either I can first reverse the address of it using reverse engineering and set that to 40, or next thing I can do is I can reverse it and find that the ammo address is always 4 bytes away from player. So I can find the player address, and then I can add the 4 byte to it. I'll get the ammo address, and then I can set to 40. Or But again, here the problem is I have to reverse the player address itself. So next better thing is I find how far the player address is from game, and I find that it's like 10 bytes away, and I add that to the game address. We'll get the player structure, and inside that we know that it's 4 bytes away. We'll add that, and we'll get ammo address, and we can set that to 40. So we can basically say that ammo offset is a 2-level deep pointer, and we can represent it like that. So next time, even if we launch the game, we don't need to again reverse that. We can simply use it to find the. Also, if you are if you are lazy like me and you don't want to reverse and find all these offsets, you can use these websites. So like the first one, dump.host, the owner of these are usually updating the offsets of some of the games, and you can use unknown cheats. People there post offset of almost all the games, and on GitHub also many people post the offsets. So before I show you the communication, which is hooking and the whole driver, let me first show you a very basic hello world driver and how we can debug that. So I have here Windows virtual machine, and this is the hello world driver. Actually, before that, let me first show you the driver code. So just like in C++, we have a void main as the starting point. In driver, we have driver entry, and the good part here is that we can actually customize the name of the driver entry itself from the linker settings. So in the linker advanced, whatever the driver entry name is, you have to set that same here itself. So whenever we load the driver, it will enter the driver entry, and also we have to take care that driver itself will not unloaded. So we have to create the object of the driver itself for unloading it. So here I have the driver, and let me open a debugger. Make sure the kernel is set, and so one thing is that we can't actually load any driver into the system. So one of the ways which you can test your driver and load it is using test mode. Windows has test mode itself for debugging your drivers, and to enable that, you need to first set this command in command prompt, and then you need to reboot your system. So as you can see on the bottom right, we have test mode set. So now we can load the driver. So first we will create a service for the driver itself, and now we can start. And the driver will be loaded. Whatever in that we have put, it will execute. And if I can show you in the driver viewer, yeah, this is a driver. And for unloading, yeah. So this is how you can basically test your driver and debug if any problem is there. Because in kernel level, there is only one single virtual space. So if there is any single error, your whole system will crash. So next thing we can do is look at hooking. So when we load our driver, we can't actually communicate with it, because it's an unsigned driver and there is no any certificate. We didn't get any certificate from Windows, so we can't actually communicate with that. So as you can see, we are trying to communicate with a driver which is loaded into the kernel. We can't. But in order to do that, we can use a technique called hooking, which provides a communication path for that. So how does it work is, we find a suitable system call in any Windows driver. We can use any driver itself, and the system call itself you can call because the driver will be officially signed. And so basically what we are doing is we are hijacking that system call. We are telling him that, hey, I'm sending you this instruction, can you forward it to the driver? But it will say that I don't have any functionality to do that. So we are also giving the system call a functionality. So basically we are giving him the shellcode, which is move racks and the address of our driver, and basically then we are simply jumping to that driver. So in order to explain that in more detail, I have here a diagram. So in user mode, we have a cheat, and in kernel we have a driver. So we are trying to call the function from a user mode, but we can't do that. So we find a suitable driver, Windows driver. So let's say we use any direct text driver, which is dxg kernel.sys. And next thing we need to do is we find a system call in that. So let's say we found this system call ntopen, which I don't care what it does, but all I need is I will put this shellcode inside the system call, which is moving the address of our function to the racks register and jumping to that. So as you can see in user mode, instead of calling the R function, we are calling the system call, and system call, since we have set the shellcode, it will forward our instruction to the driver. So till now, basically what we have covered, I have shown you the basic driver itself. I've shown you how you can communicate with the driver. So what else our driver needs to do? So our driver first need to find the system call address. So like here I have the system call ntopen composition service. So first you need to find the address, then it needs to place our shellcode in that. The next thing it also needs to do is have a hook handler. So like you are sending the instruction from user mode, like I want to read, I want to write. So it needs to handle those as well. And the next thing it also needs to do is clear the traces, because when you load the driver, it will be creating some logs in the kernel, like HITB cache table or unload drivers. So you need to clear those traces as well, so that anti-cheat won't detect that. So let me show you the code of the driver which I've made. So this is the full driver which have everything in it. So just like hello world, we have a driver entry and we are calling this function. So this is the function. So here I've set the driver that driver which we are targeting is dxg kernel, and the system call that we are targeting in that is this. And this is the shellcode, the move rack jump racks, and we will be moving this shellcode in this original array. And this is basically we are preparing the instruction, and here we are writing the shellcode itself. So the driver in which we are doing that, we can't actually simply just send the shellcode, because the driver area is read only. So we need to first set that to read write, and that is being handled by this function. And this is basically hook handler, which will be handling the read write of us. So I can't like explain all this, because it will take a lot of time. But like I will be sharing this code at the end of the session, so you can like understand it. And like some of these functions are undocumented, but you can use ChatGPT and it will tell you what they does. So let me show you like this whole hooking process, what happens in the background. So we have a Windows debugger. We will be debugging the local kernel. We'll load this DirectX driver so that we can see in disassembler. This might or might not give you error, but even if it does, it will be reloaded. Yeah, it did give us error, but doesn't matter. Yeah, we can see the disassembly here, so I'll just find the system call which we are targeting. Okay. And these demos never work. Right. Okay, looks like it's not working. So basically, you'll see here is the assembly code of this system call here, and it will have the instruction and that. So here I have the kernel driver, and I would be loading it using a vulnerable KD map, vulnerable internal driver. So this is a tool KD mapper, which will be loading the driver. And as soon as it load the move racks, the shellcode, our shellcode will be copied at the first entry of this system call. And whenever we will be calling the system call, it will go to our address, our cheat driver address. So this is one of the very important slide here. So what are the detection vectors that anti-cheat will be doing? So the first one is the hook function itself. So the driver and the system call that we are using, these are very popular, and anti-cheat developers know about it. So they have made signatures for it, and if you use this one, you will be banned. So you need to find your own driver and the system call that you can target, which is unique and the anti-cheat doesn't know about it. And the second is the shellcode. This is also move racks, jump racks, very famous, and anti-cheat know about it. They have signatures. So again, you have to create a shell code of your own, which basically does the same thing, but whenever the anti-cheat may find that signature, it should be different. So next thing is, how are you going to load the driver? You have made the driver, how are you going to load it? So one of the ways that I showed you in the demo is is using a test mode. So you can load the driver and using test mode, but the thing is, anti-cheat will be checking, like if the Windows is in test mode, it won't let you run the game. So the next thing you can do is pay Microsoft some money and get your driver signed by them so that you can use it. But if it gets flagged by them, so they will easily revoke it and your money will be wasted. So the next best thing is you can exploit the officially signed drivers. You can find vulnerabilities in it. That will allow you to load your driver. So I have here a tool which is KD Mapper, which is made by the Cruz, and it basically exploits a CVE in Intel driver, which lets you manually map your non-signed drivers in kernel memory. So what I mean by manual mapping is it will allocate a memory in the kernel and simply throw a driver. So and to load your driver, you can use KD Mapper, the driver name. And one of the good thing about using this tool is it will automatically clear some of the traces which are left behind by your driver, like MMN load, HITB cache, but it will of course not clear all. So you need to reverse the NDG itself and see what kind of tables they are checking in the kernel and clear those. Also, if you don't want to use that, there are more ways you can find other drivers. So there is this KDU utility, kernel driver utility, and it has some of the vulnerable drivers like GDRV, and you can use them out of the box. The second and third link also have some publicly known vulnerable drivers. There are 20 of them, so you can use that as well. Or you can use the fourth link to find some driver that have some CVEs, and you can but they don't have any exploit available publicly. So you can find exploit on your own and use that. So this is one of the very easiest step for creating the user mode. You basically just need to call your hook function and just prepare the instruction, whatever you want to read or write, prepare those and send that, and handle the cheat logic. If you are making Aimbot, so you need to have a logic like trigonometry, math stuff. So the third part is complex, but the whole creating user mode is very easy. So let me show you the cheat which I made for Apex Legends. So this is a Wallhack cheat, and I've basically found the offset for a glow mode. It has this game has a bloodhound, some player, so it has a ability to see enemies through walls. So I have found that offset which enables that ability, and I'm simply spamming that from my cheat. So as you can see, we are able to see the enemy. Yeah. Yeah, like I said, you just suck at games. So that completes our kernel hack, and we can move to hardware cheat. So whatever I showed you earlier usually works for most of the games like Apex, Paladins, but there is one game, Valorant, which is the exception, and it has strongest anti-cheat because it simply loads at the boot itself, and I try to find a way to load my driver before that, but I wasn't able to. So I found some other means to still be able to cheat in that game. So So I've used a very not so popular technique called pixel bots, which are basically color based aimbots. So if you have played game like Overwatch or Valorant, you know there is a feature for highlighting the enemy so you can see them clearly. So turns out you can use this feature to create a program which will like continuously scan these pixels on the screen and move your mouse. So these pixel bot usually have three things. First, it captures the pixels, like it will continuously like basically record your screen, and then it will find the enemy, like it will do some color filtering to find where enemy is, and it needs to and then it will move the mouse to that enemy. So like here, suppose we have the pixel bot, we have Valorant running, and the Valorant is projecting on the monitor, and the pixel bot is reading from the monitor. So in this case, we are not actually interfering with the game's memory. So pixelbot is like very separate from Valorant. It's not interfering with its memory. So that's why it is going to be very hard for anti-cheat to detect it. And also these are very easy to make in comparison to the kernel-based anti-cheat, because you don't need to find the bypass for all that stuff. And also some people will say like colorbot is not actually, you are not actually bypassing anything and it's not very efficient. But trust me, these colorbots are one of the reason why Vanguard is still currently struggling. And for talking about the efficiency of these, and if your code is good, if your aimbot code is good, you can still make a good aimbot out of it. So the tools basically required for this are Arduino and USB host shield. And the USB host shield, you need to solder these 3 points, the green ones, so that you can connect your mouse to it and it will get the power. But you might be wondering why we need this. So like I showed you earlier, it needs to do 3 things. First, capture the pixel, which we can obviously do. Maybe we can use the OBS, or we can write our own in Python. The second is finding enemy. That also we can, like it's basically a logic. And next thing is the movement mouse. That is the problem for the anti-cheat itself. So it sees like you have your mouse, but you're not moving it, and still on the screen it's moving. So that's the problem for anti-cheat, and for that we will be using any external device which will be moving the mouse. So how did we end up here? Like you can say like there are some Python libraries or any external libraries that can still move the mouse. We don't need any Arduino or any other stuff. So let me show you a history of how these pixel bot evolved to this stage. So initially, let's say the Gen 1 pixel bot. So initially they were using the libraries that are available in all these other languages like C++, Python, and some of these libraries still works, but in case of Valorant, none of these works. So in Gen 2, when these were blocked by the Valorant, so people started using third-party drivers. So interception is one of the drivers which basically simulates mouse and keyboard. So it became popular, and the anti-cheat came to know about it. They simply blocked it. And the next thing people started using is mouse drivers. So if you have used a mouse for Razer or Logitech, they have software like Razer have Razer Synapse, Logitech have G-Hub. So they have macros in that, using which you can automate the mouse movement. So people starting using those drivers to automate it, and again they got blocked. The next thing they started using is finding some Chinese mouse drivers. This one is also one of the famous, and again it got detected. So next thing people started using was external devices. So the thing which is good with this one is the mouse movement command is actually not coming from within the system. So as you can see in previous one, Gen 2, Gen 1, all these were coming from, mouse movement commands were coming from within the system. But in this case, it was coming from an external device. So anti-cheat don't actually know whether it's actually a real mouse or whether it's coming from any external, like, simulated devices. So again, but if you see in this thing, the main problem that this thing has is we have connected two mouse. So Valorant can say that why do you need two mouses for while you are playing the game? Like, one is for the moving mouse, one commands are coming from external devices. So in order to fix this, they simply blocked second mouse. So even if you now play Valorant and you have two mouses, one of them is not going to work. So as you can see, like, we had here two mouses, so that's why how they were detecting it. And the next thing is, in previous one, they basically blocked on the physical level, like higher level, but they forgot to block it on the lower level. So people started using hypervisor technology to simulate the mouse movement. Then again, this got detected, and people next. And the next thing is Gen 5. So this is what currently is working for Valorant and mostly all other games. So here what we are doing is, we have the mouse, we are connecting to the Arduino. And for Arduino, we don't actually have a port for connecting the mouse. So we are using a USB host shield. We are connecting on top of Arduino, and the mouse is connected to USB, and this is connected to the PC. So if you are able to spoof this setup, you can basically see that only one thing is connected. So if you are able to spoof it, the Valorant will not actually know whether it's a real mouse or it's a simulated mouse. So this is how it will look like if you are able to properly spoof the Arduino. Like, you can see, it's still showing that our real mouse is connected. So let me show you the Pixelbot code. So basically, our Pixelbot code needs to do four things. It needs to capture the pixels. Then it needs to do the color filtering and calculate the coordinates, like where is the enemy, and send those coordinates to our Arduino. So I have here a very basic Pixelbot code which is written in Python. We have here some libraries, and we are using OpenCV for color filtering. And for communication, we are using COM serial port. And here is basically the logic for color filtering. As soon as we press our left mouse key, it will start capturing the screenshot, converting those to binary image, and finding where the enemy is and how far is it away from the center, like from our crosshair. Now it will send this to this function, and it will send this to the Arduino. And we need to convert these coordinates into an unsigned integer, because we can't send a negative value on Arduino. So one of the challenge with this Pixelbot technique is that basically if you are targeting the purple color, so you'll find in the environment there is also purple colors. So you don't want your aimbot to be aiming at those trees instead of enemy. So in order to do that, you need to find the perfect color range, color filtering. So as you can see, we have here Aggarwal and we have enemies, both are purple. But if we use OpenCV, if we find the perfect range, we can filter out where the enemies are. And for that, this is a very basic code which you can use. Basically, just capture the screenshot of what you are targeting and play with the HSV ranges and filter out what you want to target. So next is the Arduino code, And the Arduino needs to do three things. It takes the coordinates from your Python code and it simulates the mouse movement. And one thing it also needs to do is simulate your real mouse. So let me show you the Arduino code. These are some of the libraries, and these are global variables which we will be using for simulating our real mouse. This is the mouse parser, which will be taking the input from our real mouses and some of the functions which are setting those global variables. And this setup function is mandatory in every Arduino code, where we are initializing all the mouse and serial. And this loop is also this setup function only runs once. So, and we have loop function, and this also is mandatory and it keeps on looping. And this logic is for the real mouse, our mouse, and this is the logic for simulated mouse. So whenever there is any data in the serial, in the COM port, it will read that and it will again convert this to signed integer, because we were first converting it to unsigned, and now it needs to convert it back. And here we are sending the mouse movement. So this whole code is doing both of the things. So it is also handling your mouse and simulating the commands from the Python code. So if you have seen in the code, we are using serial for communication. And you can also use other things like web server or wireless transmitter. But serial port is very fast. So why I've shown this is because of this. So Vanguard is actually monitoring this serial ports since many people are using it for communicating through Arduino. So, but that doesn't mean like if you are using COM port, you will be banned. So basically, people which are getting banned from this COM port is because they are using the public available cheats. So those cheats are sending some commands like those X and Y coordinates, which Vanguard have made signature for. But it's up to you how you want to send those X and Y coordinates. Like you can encode those, you can like add some prefix and prefix, basically so that the signature will be different and the Vanguard will not know about it. Also, one of the things that you can do is spoofing the Arduino. So if you go to this file, you will find there the Arduino, and you need to change the name of it. Like you can change your to Razer Viper, and the vendor ID and product ID you can get from this URL, and you can change that here, and also the product itself. So after doing that, and then if you again push your code from Arduino, like you will find your the spoofed board here, and you can select that, and again you can upload that to Arduino, and whenever you will upload, you'll connect to Arduino, it will be spoofed from this. Now I won't tell you like if only doing this is okay for Valorant, but you need to figure it on your own whether this will work for Valorant or not. So I have here 2 videos for Valorant where I've shown. First is I've simply recorded it from OBS. This is not showing the setup. I have second video also. So I'm just pressing the left key, and it's automatically aiming at the enemy. And I have a second video which is also showing the setup. So yeah, I'm just holding my mouse. I'm not even moving it. I'll just press the left key, and my mouse is connected to the Arduino, to the USB host shield, which is connected to the Arduino, which is connected to the PC. And I'll just press the left key, and it will keep on finding enemy and targeting. I have to readjust the mouse to the nearest enemy. Yeah. So what can Valorant do about this? So one of the ways they can counter these pixel bot is simply remove those outlines. In fact, recently Valorant made a patch in which I think they are testing this. So recently they made this patch where user can disable these outlines. So I think in the future, what they're trying to do is they will basically remove these outlines, so making these pixel bot useless, because you can't find those enemies if they don't have any outline. But still, there is a project which is using YOLO AI. So even if they are removing the outlines, this guy have made AI Aimbot. So if you have enough data sets for this AI, you can use it, and the AI will actually find those enemies. So you don't need those enemy outlines. So this is where you can find the code for the kernel and Arduino. I think it's still private. I will just, after this video, I'll make it public. And these are some of the references. So the first one is guided hacking. It's very useful if you are new to this field, but it's paid one. And the second is unknown cheats. It has everything for beginners to advanced, but you need to research it on this, because it's a form. People post stuff and you need to find. And this third guy has great videos for kernel level drivers. So this is the conclusion, and we're done.
Well, thank you very much. Are there any questions from the audience? Yes, sir.
Do you have tried to use a second PC with a stream link to control the Arduino to avoid any binary on your main computer?
For moving the mouse using some other PC?
Yes. So maybe can create a board on Arduino with two outputs for mouse, one for your main computer where you're playing to the game, and a second USB port for the second computer to send and control the Arduino.
Yeah, it can be done. Actually, initially before this Arduino thing, people used to use secondary PC for moving the mouse. But some guy posted on unknown cheat about it as well, about this using second mouse. And some people got the idea, like, we can also use, if you are able to use second computer for mouse movement, you can also use some second device like Arduino, or maybe you can use Raspberry Pi as well.
Any other questions?
Hi, a question regarding Windows kernel drivers. So, do I understand correctly, in order to load an unsigned driver on Windows, you just download any old signed driver, load it, exploit it, load your own stuff, and then unload the original one, and you have loaded an unsigned kernel driver in Windows?
Yeah.
Okay, thanks.
Anyone else got a question? No further questions? Then I would like to thank our speakers very much for this talk.
Thank you. Thank you.